I've been following the development of Unity's ECS since it was introduced about a year and a half ago, and I've made a few videos about it. Here I just want to talk about some problems I see. This is going to be kind of a rough draft video, hence Comic Sans for the font. I can't say that I've put Unity ECS to serious use in a real proper project yet, but at this point I think hardly anyone has. There are key pieces that are still not in place, and what's already there is evidently still in flux. And so there's still time for these problems to be addressed, and I hope that they do get addressed. Anyway, the first problem I see is perhaps really just a messaging problem. At its core, ECS is basically just a way to structure data and also code. And the general idea is that the entity component structure is a way of laying data out in memory that is much more cache-friendly and therefore much more efficient. And that's all true. The problem I see is that the entity component structure is both awkward and suboptimal for cases where you need to make relations between your data. If I have an ordered list of things or a hierarchy of things or some kind of interconnected graph, expressing those relations in ECS is doable. From one entity component, you can reference another entity, and that works fine for cases where the relations are an incidental part of the data, like something that's only utilized in minority cases. But if it's like a really key thing about what your code does is to traverse these relationships of the elements, then it gets really awkward and also suboptimal. It's not really efficient because the ECS structure is all about, I'm going to go through all these entities with a certain set of components, and as I iterate through them, I'm going to operate upon each one individually. But anytime you follow a reference from one entity to some other entity it might reference, well, that's an expensive lookup. In fact, even more expensive than in a conventional object-oriented structure because you have to use a lookup table instead of just following the memory address. So it's even more expensive when you follow references. And while perhaps this may not be the predominant scenario in most game code, that's the bet that ECS makes, that these relation traversal cases are a minority of your logic, well then on the whole, sure, ECS is a great benefit. But because I think in principle games can be about anything, I can imagine cases where traversing relations between my elements of data is the primary case, the thing that is the bulk of my code logic and also the thing that's going to kill my performance when it's expensive. So the point here simply is that obviously there's no such thing as a universally optimal data structure. There's nothing that is ideal for all possible cases. The bet with ECS is that we have this entity component structure that is optimal for most cases, and that seems valid to me. It's just there are clearly exceptions is the problem. In their messaging, I don't think Unity has made this clear. I think sometimes they've just been overeager to sell it to the point of being misleading. From what I've seen on forums and talk about ECS, particularly from people who aren't really bought in, people who aren't like regulars on Unity's ECS forum, I see a lot of confusion and consternation about, wait a minute, this doesn't make sense. What about such and such system for my puzzle game? What about such and such inventory system? Like relations are key to my game logic, and you're asking me to structure the data in a way that's both very awkward from the standpoint of my code simplicity, and then also actually even a drain on performance, not a benefit. Let me give a concrete example. Like say you're making a chess game. The most obvious way to represent a chessboard is as an array of squares, and you just have 64 slots in your array, each one representing a square, and the value in the square represents what piece is currently occupying that square. And so when you do your logic of like how you can move your bishop diagonally, you just figure out, given the structure of the array, you can traverse and see if your bishop can move diagonally in such and such direction, right? If it's not blocked by other pieces or whatever, right? If there is a way to do that kind of logic in ECS, which I'm sure there is, it's just really, really obvious and strange and weird. It's a kind of logic that requires bringing together and analyzing simultaneously many disparate pieces of data, which is not what ECS is about. ECS is about you're going to iterate again through all these things that have this certain set of components and process each one independently of the others. For very abstract game logic problems like moving chess pieces on a board, I'm sure you could figure out some way to represent the logic that way. It would just be very strange. To be clear, I'm not saying that you want to stick with the old game object component structure. Regardless of whether I use ECS or game objects and components, I wouldn't represent my chessboard as a bunch of game objects. I basically put together my own custom data structure, where the data doesn't have to be spread everywhere in memory. It can be reasonably spatially coherent. But I think it's clearly an example where the entity component structure just doesn't make any sense. It'd be very, very strange. Now, when it comes time to render my pieces, maybe I take my board representation, the 64 slot array, and keep it in sync with an entity component representation of the presentation of the board. That'll make sense to me. But when it comes to the game logic itself for this kind of problem, I don't want to have to think in terms of entities and components. I'm sure there are plenty of game logic problems that do fit well enough in the entity component model, but what I'm saying is there are problems that clearly don't. Again, I think this is not really a problem with ECS itself per se, it's just a messaging problem, it's an education problem. Anyway, the second problem I see with ECS is the verbosity and inelegance of the API in parts. The most obvious part of the problem, and something really easy to fix, is that simply some of the API names are just really way too verbose, unnecessarily. This is mainly because the type names they've chosen for a lot of the key things are just unnecessarily verbose, and then that pollutes everything else because you have all these methods that include the type name, the full type name in the method name, and now the method names grow out to be way too long. And not in a helpful way, not in a way that makes it easy for learners. It actually just makes it harder because you end up with these German compound names where if you're unfamiliar with the elements involved here, like nsimulation entity command buffer system, is it an entity command and a buffer system? Is it a command buffer that's an entity, but also a system? No, you have to recognize that there's a thing called an entity command buffer, and there are entity command buffer systems, and this is the nsimulation version of that. But if you don't already know that, this is totally unhelpful. Like it's more confusing than meaningful from the verbosity of the name. So the really obvious ones that jump out to me are that you have what they call an archetype chunk when there's no other kind of chunk in the API. I mean, I know internally they have something called chunk, and so I think they called it archetype chunk just to distinguish from the internal chunk, even though publicly you only deal with archetype chunks. So this should just be called chunk, obviously. The archetype's not adding anything. Chunks have an archetype, so why call it an archetype chunk? It doesn't make any sense, really. And then entity query. You don't have to call it an entity query. There's only one kind of query in the API. When you add different kinds of queries in the future, perhaps then you can add variants, but entity query, what they call an entity query, is obviously going to be the key kind of query you do, so it should just be called query. And then entity archetype, again, there's no other kind of archetype in the whole API, so why call it entity archetype? Just call it archetype. Entity command buffer, sure, it involves a buffer of commands concerning entities, but you really have to look at the docs before you understand what it does anyway, so it might as well be called something simpler. And if what it does is it records and then plays them back later, I would just call it a recorder. So this is the obvious starting point. I would even go further, though, and say that the terms component and system are really non-ideal. I understand that ECS is an established thing, and so you would want to stick to the existing terminology, but it's not too late, I don't think, to change this. Entity, the term is okay. That doesn't mean anything already in Unity. Component is overly long, given how commonly it's used, and it obviously creates enormous confusion for people first coming to ECS. It creates enormous confusion with what they already call components in Unity. It's absurd because every time I talk about components in a video or in a text that tries to explain what's going on, I have to specify, oh, no, entity components, not game object components. You have to retroactively go back and call the old component something much more verbose. So this is a huge problem. It's really dumb. So you could just call it comp perhaps, and so you could stick to the ECS abbreviation. This is better, but I think still unnecessarily confusing with the old components. I would invent a new term. So I thought like maybe datoid or datum, and then I thought just dat. Just call it a dat, piece of data. Coin a new term, it's worth it. It's actually easier from a learner's perspective if you just coin a new term. And then we have system, which is problematic in two ways. One, if you say entity component system, people of course think you're talking about a system of entity components, but no, it's an architectural pattern where you have three things, and system is one of those three things. It's one of the nouns. So that's totally unnecessarily confusing. And then system is just overly broad. It's overly generic. It could mean anything. Whereas really what it is just in your update loop, you have a series of steps. Each system is a step in the process. I would just call it a step. Maybe there's a better term, but step is pretty good, and it also starts with S, so you wouldn't have to change the S in ECS. So again, these better terms make it easier to talk about these concepts and not get confused with old concepts like the old components. But then on top of that benefit in the rest of the API, when you include these terms in the names of other things, those things get shorter too. So instead of iComponent data, which I don't know why it ever had data at the end anyway, let's say it's just called IDAT. And then component system, I don't think it needs to include the word component or any equivalent to begin with. So that can just be step. And then job component system, I would just call job step. Again, I don't think it's too late to change these terms. Maybe you can come up with something better than dat and step, but component and system are really problematic, and they should be changed before it's too late. From the learner's perspective, this stuff really adds up. You're trying to learn this thing with all these unfamiliar pieces, and if the terminology is unnecessarily verbose and confusing, it makes it awkward to talk about the thing, and it's just a constant drain on the learner's attention. Now, even if you make the names in the API less verbose, the API, because it really is more like a framework and is imposing structure on our code, it feels like it's introducing new language constructs. It really is kind of a problem that C# doesn't have macros. Most job component systems and most systems that people write are going to follow an established pattern, yet this repeated pattern is not captured in any syntax. And so when you're browsing around code, say, and reading a bunch of unfamiliar systems, you have to be careful and check to make sure that it is just following the pattern. Like if 90% of your job component systems just don't do anything unexpected, they follow the usual pattern, you still have to be careful when reading code to make sure they follow the pattern. So you have all these systems that typically aren't very large in most cases, and yet you have to read them carefully. And so this is why it's non-ideal that we don't have macros. So here, for example, this is code from the Angry Bots demo. This is the collision system. It's a job component system, and it creates 3 queries. It, in the update, sets up the jobs, scheduling them, sets up the dependencies between them, and then here's the actual work done in the collision job, what the collision job takes in, and what it actually does in its execute method. And we have just this additional helper method down here. As you can see, this is about 96 lines, and as an experiment, I've taken this and rewritten it using my own invented macro syntax. So just imagine that C# had like some kind of top-level language construct macro system. I'm not proposing this necessarily as what they should adopt, but I'm just demonstrating what it could look like and what the gains would be. So this macro expresses all the same things above. It makes a number of things more convenient. Things that have to be expressed in multiple places are just expressed in one place. I won't explain the whole thing, but for example, here we have to define 3 separate queries and give them names, which is a problem when you have to name things that are only used in one place. That's always a burden because naming things is hard, naming them well. So here we can just keep them anonymous. We just define, hey, yeah, we're going to create 2 jobs, one called EVB, one called PVE. Here are their dependencies. This one takes the input dependencies passed into update. This one takes the other job as its dependency. And then here's what queries they use. It's just defining after the colon, it's defining an anonymous query that it's going to use when it's executed. And then down in the update code, when we have proper C# code, it's always in curly braces. So we're dropping into C# syntax here, and this is just the code that runs upon update. Notice we don't actually schedule the jobs. That's done implicitly for us. We just set the fields of the job, in this case just radius and other trans, because the health and the trans, those are component types that are hooked up for us. The macro is automatically configuring for us the, what's it called, the archetype chunk component type business is doing that for us behind the scenes. Again, I won't explain all of this. I'm not attached to the particulars of it. I just wanted to demonstrate, hey, if you did adopt a macro system, you can get some really big wins because this is fewer than half the total lines. It's, well, close to, fewer than half the lines. And I think in terms of character count, it's half as many characters too, which is partly because I've changed some of the names to shorter names, but mostly it's because we're just getting rid of a lot of boilerplate. Anyway, if we could have macros like this, you get most obviously more concision. It also, an important thing about macros is that they can sort of clamp down on possibilities. The problem with the API implemented as just straight C# code and regular methods is it allows too much freedom, which sometimes you need, and so sometimes maybe you don't use the macro, or the macro is sort of special outlets so that for cases where you need to do something strange that's not part of the usual pattern, you can fall back to custom behavior. But the great thing about a macro like this is that when I look at it, I can be assured that it's not doing anything strange, that it's just following the regular pattern. I don't have that assurance when I glance at this code up here. I've looked at the code and inspected every line to make sure it's not doing anything strange, but I don't know that at a glance. Whereas with the macros, you can much more easily at a glance see that it's following a regular pattern. Now, obviously, implementing a macro system or some kind of preprocessor that C# doesn't currently support is a huge ask for Unity to do. I'm sure they've had many internal discussions about this. Even a straight preprocessor that would take this macro code and spit out a C# file, writing that preprocessor itself is not really the problem. The problem is now you have to support this more complicated build chain. And now you have a tooling problem where you're working in this custom syntax that Visual Studio and other editors don't support. So that's a huge problem. So I understand why they haven't bit this bullet. but I'm not confident they'll ever find a way to structure the API to get close to this level of concision and clarity. I just don't see how it can be done, and there really is a large gap in clarity and concision. Anyway, something to think about. If you're curious about what's going on in the particulars of this syntax, just leave a comment. The last problem I see with ECS, briefly, is the learner's experience. So firstly, the official information they've released about dots and ECS isn't really concentrated anywhere. It's kind of spread around in too many places. This is the main page about dots, and there's not much info here on this page itself, but if you go down to the bottom, it does have links to their documentation, including the manual, the API reference, and a link to the forums. These are the main current sources, but then also fairly critically, you also have these samples on a GitHub repo, which contains some additional documentation that has a few more links. Like here is a cheat sheet, except this is out of date. This is for version 0.0, not 0.1. And you have this other page with links to other learning resources, primarily videos, but it's not including any videos beyond 2018. There's some more recent videos, and this page hasn't been updated in all of 2019 for some reason. So the information is spread around into too many places, and many of these places are not being kept up to date, including this page. If you go to the Unity YouTube page and you go through all the videos, you'll pick out some videos that are about ECS and have some more up-to-date information than what's on this page, for example. And kind of the worst thing right now is not only is all this information spread around too much, but you have a lot of outdated documents, links, and videos that include information that is not in the more up-to-date resources. And the API has changed quite a bit since those earlier materials. So there's really not a good place for learners to start at the moment. There's no clear place for learners to start. If you go through the manual, it's not really a long read because it's actually missing quite a bit of information. It's only covering really the core of the API, and it's not really going into any advanced features. And then in the scripting reference, if you look in here, I mean, there's just obvious usability problems first off. Like for example here, this is an alphabetical list, but it's confusing to scroll up and down through because you look here, some of the names are so long they hang on to multiple lines. And so I find when I scroll up and down through it too quickly, I get confused about where I am in the alphabet sometimes if my eye has happened to look in the wrong place. So, I mean, there's a really simple fix for this. You just need to go in and using CSS, you need to like indent everything past the first line so that I don't look at this and think I'm looking at the C's when I'm actually in the middle of the E's, for example. It's a very simple, tiny thing, but it reflects the larger problem here of neglect. It just doesn't feel like anyone is taking care of this site and keeping it up to date or even improving it. There are just other more serious usability problems, like the search is terrible. Like I'll enter certain method names or property names and nothing will come up in the search. So you have to search Google or search the forums to find information about a lot of stuff. And worst of all is if we click on most any of these things, is there's no information, there's no text. There are some exceptions. There's some actual, where's an example? Component system. There are cases where you get some actual prose explaining what these things do, but that's the minority. Most of this is really undocumented. All we have is information about what exists in the API, what methods and properties, but it doesn't give us any proper information. And in many cases where we get information, we get actual prose explaining what these things do, like some obvious questions are not answered. So, for example, I had this specific case the other day. Where's Entity Manager? Oh, I'm in the C. See, again, I just got confused looking at the list because of how it's hard to navigate by alphabet. Anyway, Entity Manager. Where is it? Entity Manager. This is annoying on the right because you can't scroll. I can't scroll just through this list. It scrolls the whole page. It's just a little weird and confusing. What was it? Oh yeah, create chunk. So this create chunk method creates a set of chunks containing the specified number of entities having the specified archetype. So first off, they don't say explicitly, does this create only new chunks? You're creating some number of new entities. Is it only putting them in new chunks exclusively? Either way, it should be said explicitly whether that's true or not. They also don't say what happens here when I specify the number of chunks and then the entity count, the number of entities I want to create. What if the number of entities I want to create doesn't fit in the number of chunks I specify? Like I ask for 1,000 entities, but I say only one chunk and they can't fit all in one chunk. What happens? The documentation doesn't say. What happens if I provide too many chunks than I need for the number of entities? Do I get a bunch of chunks that are empty? What happens? It doesn't tell us, and this is really critical information. So even in the cases where we do get a little bit of prose describing what these methods and properties do, we don't get proper accounts for the behavior. And so we have to resort to asking on the forums or just doing an experiment ourselves and seeing what happens. We have to play scientist to work with this API. But again, most of this stuff isn't documented at all to begin with. There's no prose describing any of it. It's just auto-generated from the code. Sure, I understand ECS is still in development. The API is quite a bit in flux, but there are quite a number of people trying to use it or curious about it and trying to learn it, trying to get ahead of this coming new stuff. But they're not really sufficiently explaining how it works. There's too much emphasis on selling the thing rather than actually explaining it. I'm sure the plans are to have much more complete documentation when this thing is actually released to a wider audience. But in the meantime, there are people trying to figure this out. You're making things much harder on them than it really should be. I mean, surely Unity has the resources for someone to take ownership of documenting this thing and actually explaining it at a level of detail that is actually needed for people to really use it. Even if most users of Unity aren't going to be touching ECS for, say, another 2 years from now, if you want to have good material for them, you really should get a head start on it. Even though much of this API surely will change, names will change, things will get added, things will get deprecated, I think there's great virtue in documenting and explaining something while it's in development, because the explanation of a complex system is a really good smell test for the quality of its design. If something is hard to explain, that's a very good sign that it needs refinement. Particularly if you're talking about the design of an API, because of course one of the most important properties of an API is its clarity. Anyway, hopefully they'll give us some better documentation fairly soon. Regardless, the next videos I make will probably be walkthroughs of some of the ECS samples, and in the course of those walkthroughs we'll introduce the unity.transforms package and hybrid.rendering. I'll probably also cover some of the odds and ends that I haven't already covered, and then probably after that the new physics package. Thanks for listening. You can reach me in the comments or on Twitter @BrianWill.